Hello everybody, welcome back to this class. Today we want to look at the equation of a cycle. Remember, a cycle is a plane shape. Plane shape is a shape that can be described by these Cartesian coordinates. Where the x axis, there's the y axis. There's positive, there's negative, positive, negative. So we have something of this nature. A cycle can either have center at the origin, or we have center at any other location from the origin. Take note of that. It's also very, very important. Now, the equation of a cycle whose center passes through the origin. Origin means where x is 0. We have something like x1, y1. Both the coordinate of x and y are 0. So that means the center is passing through 0, 0. So that's the meaning. So this also means that the center is passing through the origin. So the center of the cycle is at origin. And that's the meaning of that. So the equation of a cycle whose center passes through the origin, that is 0, 0, is given by x squared plus y squared is equals to r squared. This is how to give the equation. For example, okay, where s is the horizontal, this is the horizontal axis, that is the x axis of the cycle, this is the y axis, then r is the radius of the cycle. So if you look at something of this nature now, let's say we have a question: find the equation of a cycle passing through whose center is passing through the origin, having a radius of 4. That means the radius of the cycle is 4 and the center is passing through the origin. So remember I said the equation of a cycle whose center is passing through the origin is given by what? S squared plus what? R squared. S squared, our center is 4. Our radius is equal to 4. And the equation is s squared plus y squared is equal to r squared. That gives us s squared plus y squared is equal to 4 squared. That is s squared plus y squared is equal to 16. This will be the equation of that cycle. Or you can also say s squared plus y squared minus 16 is equal to 0. Let's remove 16 to this other side. It's as simple as this. So this for equation of a cycle whose center is passing through the, or whose center is passing through the origin. Now let's look at equation of a cycle whose center is passing through the following coordinate. Let's say we have a cycle and the center of the cycle is passing through let's say it's passing through h, k. The center of the cycle is passing through h, k. It's passing through h, k. Some people can say it's passing through a, b. Anyhow you like it, you are free to put it that way. So the equation of a cycle whose center is passing through this, not 0, 0. That means coming to a point that is not the origin of that coordinate, is given by x minus this side, which is h squared, plus y minus this other side, which is k, then square, and it's equals to r squared. So this is something like the coordinate of the x, coordinate of the y, and this is the radius of the cycle. Now let's say we have a question. We have to find the equation of a cycle. To find the equation of a cycle with center 5, minus 2. With center 5, minus 2 and radius of 2. The radius is equal to 2. So what you have to do is just to apply this formula: s, h square plus what? Plus y minus what? K minus k square is equal to r square. That will give us x minus, what is h? H is the x side of this. This one is s comma y. So this s side of this part now is h. That is h is equal to 5. Then the k is equals to this other side. The second part is k is equals to minus 2. So we're going to have this as 5 squared plus y minus minus 2, everything squared is equals to 2, which is r is equal to 2 squared. So with this now we're going to have something of this nature. Let me clean this part. So we're going to have something of this nature. We're going to have, first of all, open this bracket. So open this bracket, we have squared like this. So to open this bracket now, you said that you just want to multiply itself 2 times. You can do it that way, or you just say s raised to power 2 first, s squared, then minus that minus there, minus this 2 here times s times 5. This 2 times s times 5. 2 times s, 2s times 5, that is 10. That is 10x. Then plus that, this, not this one, this plus is constant, plus is 5 squared, which is what? 25. That's a short way to do that. That's a short way to do that. What you have to do is just to, let's say you have something like this. Let's say you have a plus b squared, and you want to open it with shortcut. This will be equal to, first of all, say a squared, then this sign there, you pick this sign there, which is plus this 2 here times a times b as well, that is 2ab. Then the last one will be plus. Whether this one is minus or plus, the last one will be plus. So solve this other one. Let's solve this other one. So we're going to have, now we're going to have y squared first, plus y squared plus y squared, and minus times minus, that is plus, plus this 2 times this y times this 2 again, that is 4y. Then the other one, remember this one is not plus, then don't forget about that step, 2 squared, which is what? Which is 4. Is now equal to 2 squared is what? 4. So at the end of the day, we'll be having, we'll click this other side. At the end of the day, we'll be having something very nice. So we'll be having, we'll have s squared plus this one, y squared minus 10x plus 4y. Now let's check 4. If this will come to this side, will become minus. So let's say plus 25. Then if you move this 4 to this side, before I never wanted to write it because of space. If you move this 4 down to this side, it will be 4 minus 4. That will be 0. Then it's equal to 0. So this will be the equation of this particular cycle. So we might be required to as well calculate the radius and center of this cycle back. For example, they ask us to calculate the radius and the center of this same cycle. So we just calculate it back. So how are we going to do that? How can we get the radius and the center of this particular cycle? Now, to get the radius and center of this particular cycle, what you do is to compare the equation of the cycle to a general form of this, for example, now let's say of this s. Remember what we started from? We started from this place, s minus h squared plus y minus k squared is equals to r squared. So if you open this one now, if you open this, you are going to have this exactly something like that. But in terms of K and H and R, not in terms of numbers like this. So let's open this now. Let's open this to see what we are going to have. Let me open that now. If you open it, look at what you are going to have. After opening it, you're going to have something like this. If you open that equation, let me first cycle that. First cycle this because this is the answer to this. This is the equation to that. So if you open that stuff, you're going to have something like this. You're going to have. Remember what you were having was what we were having before was something like this. X minus H squared plus Y minus K squared equals to R squared. So if you put this one now, you're going to have, if you put this, you're going to have S squared plus Y squared minus 2HX minus 2 y is K, KY plus H squared plus K squared minus R squared is equals to 0. This is what you're going to have. And this part, if you check, there's no S there. We call that side constant. You don't represent it with anything that don't have S or Y, we call it constant. Then if we decide to say, since one is negative, we want everything to be positive throughout. Because this one will be plus C. That will be plus C at the end of the day. Then we want this and this to be positive. So we can just say let H equal to minus, let's just say let's do it this way. Let this minus H be represented by, let's say, G. Then minus K, leave the 2, minus K be represented by F. So we are going to have something like this. If you represent this one by D, that also means that H is equals to minus G, K is equals to minus F. That's what I'm trying to say. H is equals to minus G, K is equals to minus F. So anyway, see minus K or minus this, you just represent it by those equivalent terms. So you're going to have something like this. Remember I said this one will be C, although we'll go back to that place again. Let me first of all explain the centers first before we go to the radius. So you're going to have S squared. You're going to have S squared plus Y squared. Remember I said minus H will be plus G. So we'll now use GX. Then minus K will be plus F, minus 2FY. Then H squared plus Y squared minus R squared. H squared plus K squared minus R squared, I said will be C, which is constant. We'll have something like this. In the sense that our H is empty as minus G, and our K will be empty as what? Minus F. So if you compare this to this now, you discover that C is 25. C is 25. Check, C is 25. Then 2F is this 4 you are seeing, which is equation of Y. Equation of Y. So that this is not Y squared. This is just Y. Take note. This is just Y, not Y squared. Please take note of that. Thank you. So this 2G is the equation of S, which is minus 10 there. Then Y is Y. S squared is S squared, Y squared is Y squared. So any equation of S is 2G. Any equation of Y is 2F. Take note of that. It's very, very important. Then the constant is the C here. So from this 2G, 2F now you can get H and K. So if you know H and K, you can go and get C. So how do we get C? Let's look at that now. So this C, which is counterpart, will be equal to H squared plus k squared minus arrow squared. So if you move this arrow to this side and you move this c to this side, you can get the radius squared to be h squared plus k squared then minus c. Then you cancel this, you take the square root of this other side. So that your c, so that your arrow, your radius will be the square root of h squared plus k squared minus c. Remember, your h is equals to minus what? Minus what? Minus g. And your k is equals to minus what? Minus f. So take note of that. Remember, g, 2g is the equation of what? Is equals to the coefficient of x. 2f is equals to the coefficient of y. Not s squared, not y squared, just s and y. So anything we have as the equation of s or as the equation of y, we are going to equate it to this. For s, we equate it to. Okay, let's try this. The question we just solved. The question was s squared plus y squared minus 10x plus 4y then the plus 25 is equals to 0. Now we just solved this question, and let's look at how to get the center and radius back using those formulas I just quoted. So the first thing you do, ensure that this and this are free from any coefficient greater than 1 or lesser than 1. So there should not be a coefficient with them. That should be, that's maybe visual. When it's 1, it's latent. You don't actually state it out. So remember, 2g is equal to the equation of s. What is the equation of s here? Minus 10. So by minus 10, so 2g will be equal to the equation of s, which is minus 10. So if you saw this, just divide both sides by 2. G will be equal to minus 5. Then h is equals to minus g. So if you multiply something by minus, now you're going to have 5. So you're going to have. Then the same thing, 2f is equals to the quotient of y. What is the quotient of y? Which is 4. Divide side by 2, divide side by 2. F will be equal to 2. Then k is minus f. So multiply this one by minus now. Multiply 2 by minus, we're going to have minus 2. So k is equals to minus 2. Then h is equal to 5, which was given the question before. Center to 5, minus 2. I don't know if you can still remember that. So that's settled. Now let's get the radius now. Let's get the radius of this cycle. Let's get the radius of this particular cycle now to see what we're going to have. It's a very simple thing. Let's get the radius now. Let's get the radius. Remember, I told you the radius is equals to the square root of h squared plus k squared minus 25. Okay, there's nothing to put 25 yet. Just put minus c. So we're going to have the square root of 5 squared plus minus 2 squared. Remember, h is equal to 5, k is equal to minus 2, then minus 25. So this will go with this. So what is square root of minus 2 squared? Minus 2 squared is 2 squared as well. The minus will go. So that gives us 2. So the radius is equal to 2. Remember in that last question, the center was 5, minus 2. And the radius was what? Was 2. It's as simple as this. Although we still have we do have another method, which is the completing the square method. You can also use that to look for the center and radius of a cycle. Now let's look at how to get the center of this particular cycle using maybe another method. For example, let's say we have x squared plus y squared plus 10 here plus 4y plus 25 equals to 0. Now, if you want to use another method to get the center and radius of this cycle, look at what you are going to do. The first thing, you separate all the x term to one side. You separate the y term to the other side. Separate the y term to the other side. Then you move the constant to the other side as well. So the next thing, we work out this and this simultaneously using the completing the square method of quadratic equation. The first thing, you look at this coefficient of s, which is minus 10 that is there. You take half of the square of that coefficient and add it to both sides. You add it to this side, you also add it to this other side. That's what I'm trying to see. That's what I'm trying to see. So what is half of 10? Half of 10 is 5. Then you square it. You're going to have x squared plus 10x, then plus 5. Then you square it. This 5 is coming from half of the square of this. Then plus y squared, the same thing for this. You take half of the square of this and add it to this one as well. Y squared plus 4y. Then plus 4y. Then what is half of 4? 2. Then you square it. This equals to minus 25. Minus 25. Plus, look at this. This first one, you add it to this side. That is 5 squared. Plus this one again. So add it to this side. That is 4 squared. That's 4 squared. That's how to do it. Both the two stuff you added to this side, you also add it to this other side. So at the end of the day, we'll be having something like this. We'll be something like this. Then you pick this, just pick s. Don't forget about the square. They pick this minus here, 5. Then you square it, square everything. Just pick this s, pick this next sign, then you pick this last 5 here, you square it. So the same thing, you pick this y, pick this next sign here, which is plus. You pick this last one, this inside this place, which is 2. Then you square everything. It will be equal to, what do you have here? What do you have in that place? Okay, remember what added this side was 2 squared, not 4 squared. So if you do minus 25 plus 25, that is 0. That will be 2 squared. So if you compare this one to the equation of a cycle, you discover that this stuff here is h. So our h will be equal to 5, not minus. Remember it was like this. Remember equation of a cycle is like this: x minus h squared plus y minus k squared. Everything is equal to r squared. So minus, we cancel out minus. So h is equal to 5. Look at it. This one is plus now. It means it's minus minus. That means k. If it is plus, that means k is equals to negative of 2. K is equals to minus 2. Then r is equals to, if you check, this denominator is r. This downside is r. Check it. Carrying square. R is equals to 2. So you can also get this stuff using this particular method. So let's also look at this. Look at this to get the equation, to get the center of the cycle and the radius of this particular cycle. let's say we have 4. So we have 4 x squared, 4x squared, plus 4y squared, plus 4y squared, minus 4x minus 12y plus 1 is equals to 0. So the first thing I'm going to do here, if I make these two terms, x squared and y squared, ensure they don't have coefficient greater than or less than 1. So what I'm going to do, I'm going to divide everything by 4. Now this 4 will cancel this 4 will cancel this, so we're going to have x squared plus y squared, then minus x, then just 4 divided by 4, that's 1, 12 divided by 4, that's 3y, plus 1 over 4 is equal to 0. So that's what we are going to have. So from here now, it said I use that computing the square method or the other method. So I'll just use the other method quickly. Let's see if we can get the answer. Remember what we're having is we're having x squared having x squared plus y squared minus x minus 3y plus 1 over 4. That's what we're having. So equals to 0. So our c is equals to 1 over 4. Our c is equals to 1 over 4. Then our f will be equal to, remember something like k is equals to minus f. Then 2f is the equation of y. 2f is equals to minus 3. So f will be equal to minus 2 over 3. Okay, minus 3 over 2. Minus 3 over 2. Then what about the other side? Remember that h is equals to what? Minus g. So 2g is equals to minus 1, which is equation of x. So g will now be equal to minus 1 over 2. So ensure when you are solving, all this negative should cancel all those stuff. Okay, let's just solve it out. So let's solve it out. I've already gotten the the center of this particular circle now. That's already a walkover stuff. Already got the center. So from here now, to get the center with this formula is very easy. To get the center with this formula is very easy. The center is, look at what we're going to have as a center now. Remember our center, h is equals to minus g. So if you take minus g, now what are you going to have? If you take minus g, what are you going to have? What are you going to have? You're going to have h to be equal to what? H should be equal to, take minus of this now. We're going to have 1 over 2. By f is equals to minus k. K is equals to minus f. Is equals to minus f. Take negative of, we're going to have 3 over 2. So the center of the circle is 1 over 2, comma 3 over 2. That's the center of the circle, 1 over 2, comma 3 over 2. Now the thing is, what is the radius? That's where the issue do come from sometimes. How to get the radius out. Sometimes. To get the radius sometimes do look difficult. So let's see. Our radius r, we said, is equals to the square root of h square plus k square minus c. So we already know the values of h to be 1 over 2, we square it. Then we know the value of k to be 3/2. Then square it minus, we know the value of c to be 1/4. So arrow will now be equal to square root of 1 square, that will be 1/2 square is 4, plus 3 square is 9, 2 square is 4, minus 1/4. So we go with this. So what is root 9? Root 9 is 3. What is root 4? So we're supposed to have something like this. That will be square root of 9/4. So what is root 9? Root 9 is 3, then over 2. So I'm seeing that the arrow is 3, radius is equal to 3/2. So that's what I'm seeing here. So you take note of that. So let's look at this. Find the center and radius of this circle. X square plus y square minus 4x minus 6y plus 87 is equals to 0. Let's find the center and radius of this particular cycle. So remember the first thing, this is our C, our 2f, our 2g is equal to the coefficient of x, which is minus 4. So g is equals to minus 2. If you divide by 2, that's what we're going to have. Then h is equals to minus g. So minus minus will give us what? Plus 2. So h is equal to what? 2. Just take the opposite sign of this. Just multiply this one by minus sign to get h. Then 2f is equals to the coefficient of y, which is minus 6. Then f is equals to, divide by 2, we're going to have minus 3. So that means our k, which is equals to minus f, take the minus of this, will give us 2. That is 3. So h is equal to the radius of the circle now. Take this from r is equals to the square root of h square plus k square minus c is equals. So we're going to have 2 square plus also our k. Okay, is 3 square minus 80. Take note, this is minus, not plus. Take note of that. This is minus 87, 1 plus 87. 7. So this will give us square root of 9. Here that's 4 plus 9. Minus minus will give us plus 81 to give us root 100. 87. And what is root 100? 10. That's equals to 10. So in this question now, the center of the circle, the center is 2, 3. That means s is 2, or h is 2, k. The s coordinate is 2, the y coordinate is 3, and the radius is 10. That is the properties of this particular cycle. Yeah. Alright, let's look at this. Find the equation of a cycle whose center is at origin, that's 0, 0. Alright, let's look at this. Find the equation of a cycle whose center is at origin, its center is at 0, 0. Having in radius is equal to 5 units. So remember I told you the equation of a circle whose center is at origin, is given by what? S square plus y square is equals to what? R square. So give us S square plus y square is equals to what? Y square. We have S square plus y square is equals to what? 25. This will be the equation of that cycle. Now let's quickly look at asymptotes. Asymptotes. Now, the asymptotes that is parallel to the s-axis can be found by equating the highest coefficient of, or the highest power of x to 0, and that of the y-axis, the asymptote parallel to the what? Y-axis can also be found by equating the highest power of y in the equation to 0. So if we equate the highest power of y to the equation, we're going to have value for s. If we equate the highest power of s, we're going to have value for y. Alright, we can actually find the asymptote parallel to the s-axis or the one parallel to the y-axis. For example, now let's look at this question. To find the asymptote parallel to the s or y, if there is any, or this equation, y is equals to s minus 2 over 2x plus 3. So first, let us linearize the equation. Although we can actually solve it directly by making, maybe as we make y is formula now, just check how can this denominator be 0. That will be the y asymptote. Then make s formula, check how the denominator will be 0. That will be the s asymptotes. So the most lovely way to do it is just to ensure you linearize the equation. F of cross multiply to linearize, we're going to have y times 2s. We're going to have 2sy. Y times, 2sy. Y times 3 plus 3y is equals to x minus 2. So let's move s to one side. We have 2sy minus x equals to minus 2 minus 3y. Move y to the other side because we don't actually need the y here. So the next thing we're going to do now will be, let's factor out s from here. S will come outside. We're going to have 2y minus 1 is equals to minus 2 minus 3y. So the highest power of s here now is this s raised to power 1. Otherwise, there's no s. So the coefficient of this one is this. To get the asymptote parallel to this s-axis, now we are going to equate this coefficient of this s to 0. So that is the highest power of s there. You equate the coefficient of the highest power of s to 0 to get the asymptote parallel to the y s-axis. So you're going to have 2y minus 1, which is the coefficient of that highest power of s, is equal to 0. So we'll have 2y is equals to plus 1. Divided both sides by 2, y is equals to 1 over 2 or 0.5. So this is an asymptote, and is asymptote parallel for the what? Parallel to the x-axis. This is the asymptote parallel to the s-axis. Now let's get the one parallel to the y-axis now. Remember what we're having was y is equals to x minus 2 over 2x plus 3. So the next thing now, we're going to equate the highest power of y to 0. So we don't just for linearize, we have y times 2x plus 3 is equals to x minus 2. So the highest power of y here now is this y. This y is power 1. There's no other y there. And the coefficient is this. So let's equate that to 0. We will have 2x plus 3 is equals to 0. So from here, our 2x is equal to 3. When it goes up by 2, x will be equal to cancel this, 1.5. S will be equal to what? 1.5. So s is equals to 1.5 actually is an asymptote, and the asymptote is prior to the what? To the s-axis. But if this plus close this time, we change to minus. So actually this one will become minus 1.5. So at s equals to minus 1.5 is an asymptote. So please take note of that. It's minus 1.5. So remember, to get the asymptote prior to the s-axis, you equate the highest power of s to 0. To get the one prior to the y-axis, equate the highest power of y to 0. Then you solve out the equation. That's how we rule here. So thank you.